In this section, we'll learn a different kernel called the RBF or Radial Basis Functions kernel. So again, we have our points that we want to separate, and again, there is no line that will separate them. So here's an idea. Let's draw this little mountain range over here, which is pretty conveniently drawn. Now let's move every point to its corresponding point in the mountain range, and what a coincidence. The red points end up in highlands, whereas the blue points end up in the valleys. And now we're again in a two-dimensional land, and the points are separable. Here's a line that will cut them. And what we do is, we look at where the line intersects the mountain range, we project everything down to the original line, and now we have our boundaries. They're given by these vertical cuts. Magic. Now that mountain range was a bit suspicious, a little too convenient. The question is, how do we build a mountain range that will tend to locate the red points in highlands and the blue points in lowlands? Well, here's a technique. Let's actually build a mountain on top of every point. The technical term for these mountains is radial basis functions, and we'll see their formulas later. So we built some functions that look like this, and now let's consider combining these functions. How would we do it to build a range that helps us separate the blue and the red points? Well, here's an idea. Let's flip the middle one, or multiply it by -1. And now add the three of them, and by adding I literally mean the way you add functions, so at every point just add the three heights. If we add them, we get the following function, and now we move the points up or down to the corresponding point in the mountain range. After we do this, now we can easily draw a line that splits the points in two. We proceed to draw this line, let's say at height 0.5. This line will intersect the mountain range at these points. So when we project down to the line, we get these cuts over here, which are our model. Notice that these cuts separate the blue points from the red points as we wanted. Now we can go even farther. Before, we just added and subtracted these functions, but now we can actually multiply them by any constants that we want. We can do, for example, 2 times this one, minus 4 times this one, plus 1 times this one, and let's say the sum is this. And the line that cuts this is at height -1. Great. Now we associate this model with the weights 2, -4, 1, and -1. And now the question is, how do we find these weights? Well, here's a way to do it. Here are our three mountains or functions, one on top of each point. Now under each point, let's record the value of the function at every point. So literally, how tall is the mountain at that point? For the first point, we have that the green mountain is at height 1, since we constructed the mountain precisely to peak at that point. The other two heights are small, since the yellow and the brown mountains are pretty low at this point. So let's say they're 0.08 and 0.02. Then we do the same thing with the second point and with the third point. Notice that each point will have one value of 1 on their vector of heights, since the height of the mountain corresponding to that point is 1 by construction. In general, the other values will be small, but we may have some close by points that will give us high values. This doesn't matter. And now the question is, how do we find the right linear combination of green, yellow, and brown functions which will be able to separate the blue and the red points? Well, here's where the magic happens. Let's take these three height vectors and just plot them in a three-dimensional space. Here they are. Notice that they're very close to being the three basis vectors, since they have a 1 in each of the coordinates and almost 0 on the other two. As I stated before, this isn't always the case, but this doesn't matter as long as it gives us a set of points that we can separate. And since we have as many dimensions as points, then this space is very highly dimensional, so chances are we'll be able to separate our points well. So with some luck and the application of our known SVM algorithm, let's say we're able to separate these red and blue points with this plane over here. A plane with equation, say, 2x minus 4y plus 1z equals -1. So let's remember this equation. This is going to be a useful equation. And the reason it's useful is the following. If we take the constants of the equation of the plane, then they become the constants of our model. Namely, our mountain range consists of adding 2 times this mountain minus 4 times this other one plus 1 times this other one. And the line that separates these points? The line at height -1 for the constant term. Magic!